Have you ever wondered how a massive company, with offices all over the globe, makes it feel like everyone's plugged into the same network? How does data zip from one continent to another over the plain old internet, but stay totally private and secure? Well, today, we're going to find out by following a single packet of data on its incredible journey. We'll see exactly how SD-WAN makes it all happen.
So, let's set the scene. Imagine you've got an office in, say, London. We'll call that Site A. And another one in New York, Site B. You need to send a really important file from one to the other. Now, you can't just toss it out onto the open internet for anyone to see, right? So how do you build a secure private bridge using that very public, kind of messy infrastructure? That's the exact puzzle we're going to solve.
And really, this is what the challenge looks like. You've got your two sites, and then there's this big old question mark in the middle, the untrusted internet. We need a way to create a secure, reliable path right through it. And the technology that builds this path for us, completely automatically, is SD-WAN.
Okay, before a single piece of your actual data goes anywhere, all the network devices have to get to know each other first. You can think of it like a formal digital handshake, where every piece of equipment introduces itself and proves it is what it says it is.
There are three main players in this little drama. First, you've got your sites, obviously. Then, each site has a smart little box called a WAN edge router. And overseeing the whole operation, like a central command center, you have the vSmart controller. And when we say it's the brain of the network, we mean it. It's calling all the shots.
So how do these devices all talk to each other? Well, they use a special secure language. It's called the Overlay Management Protocol, or OMP for short. This is the protocol that the brain, that vSmart controller, uses to coordinate everything and share critical info with all the routers out on the edge of the network.
And OMP isn't for idle chit-chat. It's not just making small talk. Its whole purpose is to exchange two absolutely vital pieces of information that make this entire system tick. Let's dig into what those are. First, they share their site routes. This is basically each site raising its hand and announcing what local networks it has. So Site A is essentially shouting, "Hey everyone, if you're looking for anyone on the 10.1.1 network, that's me." Then, and this is the real magic key, they share their TLOCs. This is each site telling the world exactly how it can be reached from the outside.
So what on earth is a TLOC? Honestly, the best way to think about it is as a digital business card. A TLOC, which stands for Transport Locator, has all the info another router needs to find it and build a secure connection to it right across the internet. It's the critical how to get there part of our puzzle.
So what's actually written on this business card? Well, a TLOC is made of three key parts. First up, you've got the system IP. Think of this as the router's permanent serial number. It's a unique identity that never changes. Next is the color. Now this just describes the type of internet connection it has. Is it a regular business internet line, a private MPLS circuit, or maybe even a cellular LTE link? We give them colors so the network can make smart choices later. And finally, encapsulation, which just says what security protocol we're going to use, which is pretty much always IPsec, to keep the data safe.
Let's look at a real example. The vSmart controller gathers up these TLOCs and acts like a network matchmaker. It tells Site B, hey, if you want to reach Site A, use their biz internet connection at the public IP address 1.1.1.1. And at the same time, it tells Site A, to get to Site B, you can use their MPLS connection at 2.2.2.2. Now, with this information exchanged, everybody has the blueprints they need.
All right, so now we're moving on to the next phase. With those TLOC blueprints shared, the routers have everything they need to start building that private superhighway that's going to carry our data.
And here's the absolute best part. This whole thing is completely automatic. The WAN edge routers at Site A and Site B look at each other's business cards, and bam, without anyone lifting a finger, they build these secure encrypted IPsec tunnels directly to each other right over the public internet. This is a huge reason why SD-WAN is so powerful. It replaces what used to take hours and hours of really complex manual work.
Okay, the stage is set. Our secure tunnels are up and running. Now it's finally time to meet our hero, a single packet of data sitting on a computer in Site A that needs to get all the way to a server in Site B. And there it is, the original untouched packet. You can see it has a source address from inside Site A's private network and a destination address for inside Site B's private network. Now these local addresses, they mean absolutely nothing to the public internet. They're like an inside joke.
This brings us to a really critical step.
Before that packet can leave the building, the WAN edge router does something called encapsulation. It takes our original packet, encrypts it so it's unreadable, and then wraps it inside a brand new packet with a new outer header. That new header uses the public internet IPs from the TLOCs we talked about. It's kind of like putting a private letter inside a new public-facing envelope. This is how our private packet can now travel across the public internet.
Our packet, safe and sound inside its protective outer shell, has successfully made the trip across the internet. It has now arrived at the front door of Site B, so let's check out the final leg of its journey.
The process here is pretty much the exact reverse of what happened back at Site A. It's like an unboxing video for data. The WAN edge router at Site B gets the packet, it sees that it's part of the secure IPsec tunnel, and decrypts it. Then it just rips off that outer public IP header, and inside, there's our original, perfect little packet. Finally, the router looks at that original destination address and sends it right along to the correct server. Mission accomplished.
Now that we've followed the journey of one tiny packet, let's zoom out a bit. Let's look at the brilliant big picture architecture that makes all this possible. It's all based on this idea of two separate layers working together.
So, on one hand, you have the overlay. This is the smart, private network of tunnels we just built. It's the brains of the operation. It knows all about your internal networks, and it's managed by that vSmart controller. Then on the other hand, you have the underlay, and that's just the raw transport. The public internet, MPLS circuits, LTE, it's just the muscle. The underlay is dumb. It has no clue what's inside the packets it's carrying. It just passes them along based on that public-facing outer envelope. And this quote right here, it really just nails it. The underlay doesn't know internal routes. It only forwards based on the outer IP header. That separation is everything. The public internet, the underlay, never, ever needs to know a single thing about your private company network. It's just a transport system, while all the intelligence, all the security, lives in that SD-WAN overlay. And that's what gives businesses the incredible flexibility to use any connection they want, from cheap internet to super fast fiber, without ever giving up security.